Hi everyone, it's Matchkini again here, and so I'm going to show you another QuPath quick tutorial. And this time I'm going to show you Ki67. So once again, now here I have a slide available here in QuPath that I've uploaded here, and you can see that this is a Ki67 slide with a kind of intermediate level of Ki67 staining, and so you could estimate this and see. And so what I'm going to do here is I'm going to make a area. So I'm going to make a somewhat large area here just so I can demo a few things. You could do the whole tissue, but just for the sake of time, I'm going to do just this. And so then what we're going to go do is we're going to go up to our menu here, and we're going to go into, just trying to move my zoom toolbar. We're going to analyze, and we're going to cell detection, and we're going to positive cell detection. And so that's going to then bring up this window here. And then in this window, we have a few options that we need to look at. And so I find that you can try this back and forth, but I find often the optical density sum is a little bit better instead of just detecting objects based on the hemotoxin. I find that our stain is a little bit lighter, and so I need to change the threshold. So this is basically the minimum threshold that it will find the cell. This sigma function is really useful because if you basically, you just mouse over here, show you the tooltip. So this will decrease or increase the fragmentation of nuclei. So if you basically increase this number, what that will do is it will alter, it will stop the nuclei from being over fragmented. And so that can be a really useful thing. And then down here is this basically the quantification of the Ki67. So you can have it bid into 3 different categories, but for Ki67, we want to basically count anything that's positive into one group. And so the guidelines would suggest anything that's a faint brown color should do it. And so you should play around with this number based on your own stain, but I find that this number works well for my stain. And once you're happy with it, you just press run here. And then so what it's basically going to do is going to go across each of these boxes, and then it's going to first detect the number of cells in there, and then it's going to then classify them based on their number of positive cells. And so you can see it's moving across here, and counting the number of tumor cells across. It's going a little bit slower here because I'm also running a Zoom call at the same time. But overall, it can do it fairly quickly. And you can do this some amounts of batching. So if you had a few cases you wanted to do, there is a way to set up a project file that I may work on do in another video that would then outline that process. As you can see here, I'm only just doing this area, so there's a larger aspect of the slide, and so you could do the entire slide if you wanted. So we're almost done here. So now it's then gone through all the boxes. One tip is actually when you're just trying to set these parameters for the first time is actually to start with a smaller area because it'll do it a lot more rapidly. And so now then I want to zoom down, and then this is actually the most critical part. And so in this part, we basically want to go through and then see whether there's check anything. I find this slider bar really useful because you can basically turn off and on these detections. And so basically what I'm doing is I'm going through and I'm making sure that I agree with things that it's calling. And so some people may say that that is not a positive cell, but to me, there is a faint amount of brown staining. And so any positive Ki67 should be called. So I would call that. However, that is a bit of the subjectivity to it. And you can see there's no real missing cells and there's no real over segmentation of nuclei. And so then if we just went here, we could then see that the overall positivity rate is 6.43. But you can see that we've actually counted quite a few number of cells. We've actually counted 155,000 cells. And so the Ki67 is often supposed to be a hotspot analysis. So you can actually use QuPath here to help with this. And so you could just go back to your analyze function and you go to the density map, and we can create a density map here. We can then say we're going to look at all the cells and we're going to look at any of them because we haven't made a classifier, but then we just want to see the positive cells. And then sometimes you can then turn this down a little bit so you can then kind of see. And then we're going to just update that. And then we're going to do this Gaussian weighted, which will help us. And then you can see it a little bit better when you take off that there. And then you can see here, there's kind of a hotspot of the Ki67 here. So if we actually just make a new box in this area, we can actually see that in contrast to the overall thing, it's actually a little bit higher in this area. And so just follow this number here. We can get up to 8, 7, see if we can get a little higher. And you can see even in the smaller area, we're getting up to 8.5% of Ki67 positive cells. Great. So I'm just going to close that and delete that. And I will show you one more thing with this. I'm just going to put my detections back on. And so you notice here that it's actually counting some stromal cells too. So there's a few ways you can address this. You can draw an annotation that removes around those. You can also make a classifier if you like. And so what we're going to do is we're going to actually teach the system here, what is tumor and what is not. So I'm just going to turn that down for a second. So we're going to say that these are stromal cells. And so when you're training the classifier, the most important thing is to giving it best examples as you can. And so then I'm just going to right click on this and say set class and stroma. And then in these cases, I'm going to say these are tumor cells. Set class tumor. I'll give it another example here of some positive tumor cells. There's a lymphocyte hiding in there, so I don't want that to be included. I'm going to call that tumor cells. And then let's see if we can find some areas of lymphoid cells that we can teach it that those are lymphoid cells. I'm just going to move around a little bit, see if I can find some nice clusters of lymphocytes. And there's not great lymphocytes around, so let's see if we can at least find something. Maybe for the sake of the example, we'll just leave this as stromal cells and tumor cells. Okay. So right now you can just see everything's that, and then we're just going to go to analyze, and over to classify, and we're going to go object, train classifier. There's a few different object classifiers you can use. So we're going to look at all detections. You can use a random trees, this artificial neural network, or a k-meter neighbor. We're going to use all the features. Actually, I'm going to just change this because I don't want it actually looking at the DAB because we don't want it. So we're going to say select all, but then I'm just going to take off these DAB standing here because I don't want it to utilize those features. We're going to apply that. And then we just go live update. And then it should then classify here. So you can see here that it's done a pretty good job of classifying tumor, which is in this blue, and these stromal cells here. And that was just with a very simple thing. And then if we actually go back and look at our whole thing here, you will now have then updated the positivity rate of both our tumor and of the stroma. And so it's a way that you can do a bit better job at classifying this and just getting that more pure population of tumor cells. So there you go. That's how you quantify Ki67 using QuPath. I hope everyone has a great day.